Hello, this is Mary Beth with the Young Professionals Math Bootcamp. This is lesson number 6, percentages and simple interest. And we'll do a little bit with proportions as well. The first thing to remember is that percentages are 100%. What that means is percent is always out of 100, no matter what. So even if it's over 100%, we're still talking about it being out of 100%. So you have to keep that in mind. Again, just like when we talked about decimals, and when you go from decimals to percent, you move 2 spots to the right. Why do we do that? Because 100 has 2 zeros, which is why you go 2 spots to the right. So that's the first slide we're going to look at, is a review of that. So changing decimals to percents. So I think a little trick that you can help to remember this is to think about the alphabet, if you were just to write the whole alphabet. And when you're going from D to P, you're going to the right. You're moving to the right. So from D to P, you are going to move that decimal to the right. Again, percent is always out of 100. So you move a decimal 2 spaces to the right. And there are a couple examples. 0.67 becomes 67%. 1.5, again, I moved it 2 spots to the right, so it's 150%. You can see there that I had to add a 0, because when I move it one time, the decimal's right after the 5, but I have to move it again, so I had to add a 0. So 1.5 becomes 150%. Again, the reason you want to know this is because when you're doing problems, finding simple interest, different percentage problems, you very well might have to change a number from percent to decimal or decimal to percent. So when you think about going from D to P, decimal to percent, you go to the right. When you are going from percent to decimal, you're going backwards, you're going to the left. So you would move your decimal 2 spots to the left. So on this next slide, we have some examples of changing fractions to percents. So again, whether you're going from decimal to percent to fraction, you want to know how to do all of that and go from one to the next by hand. Also, you can practice using your calculator. So with fractions to percents, here are some examples. We're going to start with 3/10. And the way we think of it is, again, this is less than 1. So you know that it's going to be over on this side. It's going to be a decimal and then numbers that follow. So if the 3 is in the 10th spot, that just means it's going to look like this. So 3/10, this is the same thing. You would read it the same way, 3/10 or 3/10. If I wanted to change this to a percent now, again, from decimal to percent, all I do is move it 2 spots to the right, and now I have 30%. So you want to recognize that 3/10 is the same thing as 0.3. That's the same thing as 30%. Those mean exactly the same thing. It's just that this is a fraction, this is a decimal, and that's a percentage. So if you have to go from decimal to percent, you know how to do that. If it starts out as a fraction, you still know how to do that because you know 3/10 is the same thing as 3/10. Another example, this is a little bit easier because it's over 10. If you had 3/100, again, I'm still talking about hundredths. So the 3 is going to be in the 100th spot, so it'd be 0.03 because it's 3/100. If I move it over 2 times, now I have 3%. But what if the number is not over 100 or 10 or 1,000? What if you have 6/7? Well, you can't just set it up as easily as that. Because you can use a calculator, what you want to do is just type in 6 divided by 7. If you type in 6 divided by 7, you get 0.857. And some numbers that follow, but we're going to round. So you just type in 6 divided by 7. This is what you get. If I need to write it as a percentage, again, move the decimal 2 spots over. So I'm going to round it to 86%. So I rounded it because there's a 7 after that decimal, so it would become 86%. Again, you want to make sure the directions might tell you to round to the nearest whole. the nearest tenth, whatever that is. So even if there's not a 10 or 100, you can always just take top divided by bottom. That's what a fraction is, the numerator divided by denominator. Also, think about whether or not that is a reasonable answer. 6 over 7, think about those original fractions. If you have something divided into sevenths, and you have 6 out of those sevenths, you've had almost all of it, right? If you have that candy bar divided into 7 pieces, you've eaten 6, you've eaten almost the whole candy bar. 86%, that makes sense. If you had somehow, let's say you typed in 7 divided by 6 on accident. You typed in 7 divided by 6. That would give you 1.16 repeating. So now you're saying you've eaten a whole candy bar plus more. Well, you didn't because you only had 6 out of 7. So always go back and double check, make sure it's reasonable, that it makes sense. Okay, the next slide, it helps set you up for answering those story problems that involve finding a missing number. So again, you want to practice this, and there are other ways you can solve for these problems. Again, I'm showing you what I have seen to be the easiest way to set these problems up, but it's not, you don't have to do it this way. So if you find another method that you understand better, or if you use this one but you kind of tweak it a little, that's fine. This is just something that I use if I'm taking a test and they give me all sorts of numbers and they're not easily reduced, then I set my problem up this way so I can make sure that I'm going to follow through correctly. So this is always true. Part over whole equals percent over 100. Again, I will say it a dozen times. Percent is always out of 100. So, and this setup is always true. The part over the whole is going to equal the percentage. It will never change. So here we have an example. And this goes back to what we did before with proportions. This will help you find percentage problems. So being able to read a story problem and know what's the part, what's the whole, and then what's the percent. Again, those two fractions, those two proportions you set up, you always are going to automatically know that 100 will be on the bottom of one of those fractions. So with this example, and I'm going to write this out. Again, it's on your slide, but what you should do on your paper is write it out as well, or add the parts. Again, I skipped some parts, so you want to make sure you're writing everything out. So we have 4 different candidates that ran for office. So candidate W received 2,562 votes. Candidate X received 1,980 votes. Candidate Y received 476. And candidate Z is 4,233. So these are all obviously very different numbers. And even though you will be working from a homework sheet or on a test, again, I would still write this out on your scrap paper. Even though it's given to you, at least while you're practicing these types of problems, I would write it out. Because you want to remind yourself the information that has been given to you. So this is how many W received, this is how many X received, and so on. And again, this might not be all the information you need. You might have to take it a step further. So the question asks, what percent of the votes did candidate Y receive? Well, we know that candidate Y received 476, so that's our part. Again, percent's always out of 100. We know the part. We know that candidate Y received 476. But what's the total? We don't have that because they've given us what each candidate earned, but what's the total? So you would add those all together. And when you add that all together, you will get 9,251. So again, this is why you want to always double check your work, because it's easy to make a mistake when you're adding this together. So this person received 476 votes out of the 9,251. So again, think about what a reasonable answer would look like. About 9,000 votes, this person received not even half of 1,000. So it's going to be a pretty low percentage. So I would take my calculator, 476 divided by 9,251, and you would get 0.0514, and it repeats, or it doesn't repeat, it goes on more numbers, but again, you're probably going to want to round. So I want to change this to a percentage. So this is not my answer because they're asking for a percent. So I'm going to move it 2 times over. So I would say they get about 5.14%. And again, that's reasonable because, again, this is a low number. This is not very many out of this total number of votes. So they earned 5.14% of the votes. So here on this next slide is another example, another question, but we're using the same information with candidates X, Y, Z, W, X, Y, Z. But we're still going to use part over whole equals percent over 100. So if candidate X received 21.40% of the vote, and there were 9,251 total, how many votes did candidate X win? So we know they're giving us the percentage. We know the percentage is over 100 because it always is. But how many actual votes is that? We know from the previous page that the number it is, but we're pretending that that information wasn't given to us. So we know after we added that it's 9,251, because that is in the first part of the question, 9,251 votes total. But we don't know how many. So X over 9,251 is going to equal our 21.4%. So when you cross multiply, you get 100x, and then you get that big number, 197971.4. And then remember, to get the x by itself, you're going to divide both numbers by the same thing. So we're going to divide both numbers by 100. So when you get that, you get 1,979 votes. So candidate X received 1,979. And again, you might get a whole number or you might get a decimal. You just have to read the directions to see what it's asking for. The next slide we're going to look at involves finding interest. Now this could be if you are borrowing money from a bank or a lender, how much interest will you owe based on the amount that you took out, or it could be earning interest in a savings account, for an example. There is a simple formula that you can use, and sometimes this formula will be given to you on a test. Whether it is or it isn't given to you, it's an easy one that you can remember, and you want to practice using it. You don't want to just assume that you're going to understand how to plug in the numbers. You want to make sure you understand what each word is. So if you're looking at this slide, we have interest equals principal times rate times time. And that's written simply as I equals PRT. And what they mean by principal is the money invested or borrowed. The rate is the percentage rate. So if you take out a loan and you are going to have to pay 6.2%, then 6.2% would be your rate. Your time is always given in years. So if it's 5 years, then you would simply write 5. If it's 6 months, 6 months is half a year, so it'd be 0.5 years. And 3 months would be written as 0.25 because 3 out of 12 is 0.25 or 1/4. So our first example, we have Tiffany put $6,000 into a savings account with an interest rate of 2%. How much money will be in her account after 2 years? So for this one, our principal is $6,000 because that's what she put into the bank. The rate is going to be 2% That's the rate of interest that she'll earn. But when we're plugging that in, we're going to use 0.02 because we want to go from percent to decimal so that decimal point goes 2 to the left. So again, if you're using a basic calculator, you're going to plug in 0.02, not 2%. And time is 2 years, so you can simply use 2. So again, my formula is interest equals principal times rate times time. So I'm going to plug in those numbers, and I'm going to use x, actually. I'm going to use x to find my answer. You don't have to. You could use I, but I like to use x. So my principal is $6,000. My rate, 0.02, because it's 2%, and then my time, which is 2 years. So when I multiply that all together, I'm going to get $240. That's her interest. But you want to remember the question is asking you how much will be in her account. So it's not $240, that's what she earned. What's in her account is how much she put in plus her interest. So it would be $6,000 plus $240, which is $6,240. So again, you have to make sure you read the question carefully. Sometimes these questions will say, how much interest did she earn? Or it might say, how much is left in her account after 2 years or 3 years. So always go back and double check the question to make sure you're answering what they're looking for. And our next slide is just another example. So we have interest equals principal times rate times time. Donnie borrowed money from his credit union to buy a used car. He agreed to a 5.5% interest rate over a 30-month period. He will end up owing $825 in interest on top of paying back what he borrowed. So again, he's borrowing money. He's going to owe that money back plus interest. So how much did Donnie borrow? Now this is one, we're given all the information we need except for one thing. So what is it that we're looking for? We know that he's going to owe $825. They told us that that's his interest, $825. The rate is 5.5%, so we're going to use 0.055. The time is 30 months. So again, we don't want to use months, we want to use years. So you have to figure out that 30 months is 2.5 years. So 24 months is 2 years, an extra 6 months, 24 plus 6. So you get 2.5 years. And then, so we're going to set up our problem using that same formula. The interest is $825. X is what we're looking for. We don't know how much he borrowed. We know that it's at 0.055 interest rate, and it's for 2.5 years. So when you multiply that all together, and when you finish that problem, you will get $6,000. So he borrowed $6,000. So it doesn't matter what information they've given you, as long as you only have to solve for one of those variables, you are just going to plug them into that same formula. Interest equals principal times rate times time. Make sure you read the question carefully to know if they're looking for just the interest or if they're looking for what's left over. And always go back and double check your work. I will see you in the next lesson.